Seized engines can happen at any time, from almost immediately after a new engine is installed to well over 100,000 miles. A seized engine is a problem within the cylinder of the engine that causes it to completely break. But why do they happen? The cylinder is the chamber where all of the engine's power is created. As fuel and air ignite inside of it, it causes high pressure gases to build up, pushing the piston downwards. As the piston moves downwards, it causes power to pass through the connecting rod onto the crankshaft. As the piston moves upwards, it compresses the air-fuel mixture, pushing out exhaust gases and keeping the cycle moving. The connecting rod serves as a link that transfers this back and forth motion of the piston into the crankshaft, allowing it to spin smoothly. To attach the crankshaft and the connecting rod, the crankshaft end is divided in two and then put back together with the crankshaft inside and a crankshaft bearing between the two. The crankshaft bearing acts as a pillow. Without the crankshaft bearing, the two metal parts would be grinding up against each other. Now, a seized engine usually happens when increasing the efficiency of the engine. This is usually done in two ways. First, by improving the fuel-air mixture or just making the combustion process more efficient in itself. And the other way is by increasing the pressure within the cylinder. To make the engine combustion process more efficient, we can focus on proper maintenance of the engine, such as cleaning filters, having good oil, ensuring clean injectors, and maintaining good spark plugs. Another way is better fuel-air delivery. This means cold air intakes or higher pressure injections. Reduced friction is also very effective, so by having lighter parts or low friction oil. Lastly, advanced technology like turbocharging forces more air in, creating a stronger, more complete burn for better power and economy. All these factors ensure that the fuel-air mixture is at its optimal ratio and that the engine is running at its fastest, reducing waste. When increasing pressure in the cylinder, there is added force on the piston, the connecting rod, and therefore the crankshaft. To compensate, we must harden the crankshaft bearing to sustain any added pressure. However, this has a negative effect, as any debris that is near the bearing will get stuck on the surface as opposed to being embedded by the bearing. As seen, when we divide the crankshaft ending in two, there's risk of metal particles getting stuck on the surface of the bearing. If this is the case, the metals will grind up against each other, causing friction and thus heat. This causes the metals to expand, causing them to jam up against each other and causes the engine to stop. So that's why engines seize, a small problem that, if ignored, can bring even the strongest machines to a stop. But when we understand how they work, we keep our trucks and cars moving forward, mile after mile.